In this lecture, we'll talk about definitions of ellipse. An ellipse is the set of all points in a plane that the sum of whose distances from two fixed points in the plane is a constant. So in the definition right here, we are given two fixed points. Those two fixed points are called foci. Down here, those 2 points are fixed. Okay, are given, are fixed. If 2 points are fixed, then the distance between those two is fixed. Remember that. Okay. Then if we do in this way, you see this point has a distance between this one and this one. And this point has a distance between here and here. The sum of the distance means you add this one and this one together equals the sum of the distance, those two. Okay? Yeah, if you see the distance between this one and P, between this one and P, there are two distances. You add together equals the sum of the distance. Add those two together. Okay, that's what it says. Okay, so you see it right down here. If you move this pencil in this way, you'll get the ellipse. Okay, you see, since those two foci are fixed and distance is fixed, but the sum of the distance is always this long. It's not changed. Okay, so we may assume the sum of the distance, here the constant, let's say, is a constant. Let's say this constant is 2a. Why do we want this one to be 2a? It's because, if I move this point to the middle between those two, in the middle of these 2 points, then each one gets a, because there's a middle one in between those on this line. Each one gets a, so let me mark it. The right-hand side, this one is a. Okay, that's the one thing we want to be clear. This one, dotted line, has a length a. Okay, since those 2 points are fixed, then we may give the coordinate for this one is C0. Then this point will be negative C0. Again, those two are called foci. There is an intersection between this line and the ellipse. Those 2 points are called vertices. Each one is called a vertex. We don't call this vertex. We only call this 2 vertices. And then between here and here, those 2 vertex, we call it a major axis. Between this point and here, we call that minor axis. Okay, it's shorter. Yeah. And the major vertex is longer. And you see right down here, the foci is always on the major vertex. Okay, that's the thing we want to be clear. Now is that we want to find out the equation of this one. Assume there is a point which is pxy on the ellipse. Okay, so this pxy stands for any points on this ellipse. Okay, and then there is a distance between P and left focal point. How to calculate that? Between P and the left focal point, that's x minus negative c plus y minus 0. X minus negative c squared plus y minus 0 squared. Then choose the square root. That's the distance between this point, P, and the left focal point. And add this distance between this P and this one. The only difference here was negative. Here was positive. So x minus c squared plus y minus 0 squared, choose the square root. Okay, if add those two, this distance with this distance together should be 2a. Okay, that's a constant. We assume it's 2a. Okay. Alright, now let's find out. You know, this equation is a very ugly equation. Okay. Now, let's find out a beautiful equation. Okay. Let's go back a little bit. I'll introduce you another constant. Another constant is that, again, we know this side is a. From 0 to the right focal point, we know is C0. So this one will be C. Okay? This one will be C. Now, let me mark it. Okay, so this one will be C. Now you know this is a right triangle. This is a right triangle. Let me mark this part with B. Okay? This part, from this part to this part is B. So, then probably you agree you have a squared equals b squared plus c squared. Okay? Yeah. Alright. Now, eventually, this equation, one right here, very ugly one, will come to be the one like this. X squared over a squared, this one, plus y squared over b squared with this one equals 1. Where is c? C disappeared. But you know, c, how can we find c? Because b squared plus c squared is a squared. So that's the connection between a, b, c. So from here, we know a should be below x and y, b should be below y. That's exactly true, and you will see that. This is b. Okay. From here to here is a painful process. Okay. X squared over a squared plus y squared over b squared is 1. This is a standard equation. We got it from here to here. How? Very long, but it's not hard to figure out. Let's do this. Okay? Look, there are 2 square roots. Not easy for us to handle. So we move this one to the right. The way we do that is both sides subtract this quantity. That's right here. Okay? Minus square root x minus c squared plus y squared on both sides. So you get these two disappeared. They cancel each other. Left hand side, you have this one left over. Right hand side is 2a minus this quantity, square root x minus c squared plus y squared. So then you can choose the square on both sides to get rid of this square root sign. So it disappeared. And then 2a minus this quantity, square root of this quantity, you have to square that. That's the hard part. You got to do the FOIL method. Okay? Remember 2a minus radical x minus c squared plus y squared is 2a minus radical x minus c squared plus y squared. Okay? If you square that. If you FOIL that, you'll get this one. 2a times 2a is 2a squared. 2a times this quantity negative. And this quantity, same quantity times 2a. So that's why you have a double 2 down here. And this quantity times this quantity with square root. Eventually this square root sign will disappear. Because of the square down here. Alright, let's move on. Before we move on, we want to see is that x plus c squared can also be FOILed out. That will be x squared plus 2cx. If you FOIL that, you'll find out. And then c squared plus y squared. And here is the same thing, because you have squared, choose the square root, so we don't need this square root anymore. Those two are almost the same, except here is negative. So then you have a negative down here. Rest of 3 times x squared, c squared, plus y squared are the same. Since they are the same, if we subtract x squared on both sides, they will disappear. Subtract c squared, they will disappear. Subtract y squared will disappear. And here is minus, here is plus. So if we add 2cx on both sides, then what we get is this will disappear. And this left hand side will be 4cx. That's the one right here. Right hand side is 2a squared, 4a squared. 2 times 2 is 4a. And then we still have this quantity. Now, we need to get rid of this square root sign. So we take this one to the left. Before we take this one to the left, you see they all have a 4. So we divide 4 to all of them, we get 1. And 1 times anything is that thing. So then what we have is cx equals a squared minus a times this quantity. Okay, remember, we just want to get rid of 4 at this step. And we also need to move a squared to the left, because we want to get rid of this square root sign. So minus a on both sides. Okay, then this part will disappear. And the left will be negative. Left hand side will be negative a squared plus cx. Right hand side, you only have this one left. Is because minus a, they will cancel that. So now we are ready to get rid of this square root sign. Is we square both sides. Okay.